Are you ready? All right, an equilateral triangle and a regular hexagon have the same area. The ratio of the side length of the regular hexagon to the side length of the equilateral triangle can be written as m divided by the square root of n. We want to know what n plus m is. So, whenever you see an equilateral triangle, the first thing you should be thinking is 30, 60, 90 right triangle. Because an equilateral triangle has 60-degree angles, and the first thing we're going to be asked to do is to divide it in half to find the height. Because we need to know the height in order to find the area. And so right now we have two 30, 60 right triangles. So we have to recall those rules right away. So let's do that first. So if I have a 90-degree angle and we call this 30, if this side length is A, what is the hypotenuse? Do we remember what this is, please?
Is it like 3 times square root of, wait, 2a?
It's 2a. And that makes sense because if I call this A, clearly this side length right here, of course it didn't show, this side length right here is twice,
yeah,
because I broke this part in half. So then the height of the 30-60 right triangle is going to be the shortest leg times the square root of 3. Does that ring a bell so far?
yes.
Walt, are you doing good?
Those kids have like
Kind of.
toys.
Kind of. I know.
I thought it was baby goats or something.
Yeah, the kindergartners are having like superhero day and they have kazoos and it's really obnoxious right now.
I remember the last day of
That's
school,
what you think it. It's not. It's not.
years ago they had whistles or something. They're all like,
Yeah, it's not. It's just obnoxious.
No, them running around in their
Adam,
costumes,
come here.
cute.
Bring me that. Bring
Kazoos,
me
not
that.
cute. All right, so looking at this triangle, we know that 1/2 base times height is equal to the area, right?
yeah.
So
Yeah.
I'm going to call this side length A. Why? Because I want to. Which means that the base of this whole triangle is going to be 2A. So we have 1/2 times 2A, and the height is A times the square root of 3. Because it's a 30-60 right triangle.
Yeah.
And so let's simplify this a little bit. 1/2 times 2 is 1. A times A is A squared. So the area of this triangle is A squared times the square root of 3. So we know that up front. And we're not going to worry about the squared so much because we're pretty sure squared is going to happen in the hexagon too. So then when we're looking at the hexagon can just be thought of as 6 equilateral triangles. And as we've already said, the equilateral triangle is really just two 30-60 right triangles.
There are 12, 30, 60 right triangles.
So
12. But do we have to use B's or something instead of A's?
I'm going to use H for hexagon.
Ooh.
An A for
Well,
a triangle.
yeah.
Wow.
So we're using H for hexagon, A for triangle, because the triangle looks kind of like an A.
Yeah, actually.
All right, so I'm going to call this H, which means that the base of the of this equilateral triangle is 2H, and the height is going to be H times the square root of 3.
No.
Have I lost anybody so far?
No.
Good.
No.
All right, so the area of the hexagon is going to be, well, we have 6 of these triangles, and the area of a triangle is 1/2 times the base, which is 2H, times the height, which is H times the square root of 3. So let's simplify this a little bit. 1/2 times 2 again is 1.
Gone.
So we get 6.
Or 1.
So we get 6 h squared times the square root of 3.
Yeah.
Is everybody with me so far?
Yes.
Yes.
Okay, so we know that a squared times the square root of 3 is equal to 6 times h squared times the square root of 3. And we don't have to find a, we don't have to find h, we just need to find h over a. That's what we need to get to, because remember, it wants a ratio of the hexagon to the triangle. So we're just trying to find h over a. All right, so I'm going to write my equation up here so I have a little more room. So I have a squared times the square root of 3 is equal to 6h squared times the square root of 3. All right, so my next step is I need to get the a squared on the other side because I need it in the denominator. So I'm going to divide by a squared, divide by a squared. So now I have the square root of 3 is equal to 6h squared times the square root of 3 over a squared. It's really not too bad. Don't freak out yet. So then, again, I want the h by itself. So I'm going to divide both sides by 6 times the square root of 3. So just doing simple train tracks. Divide everything by 6 root 3 divided by 6 root 3. And I get 1 over 6 is equal to h squared over a squared. Because the square roots of 3 cancel out. So that makes it a lot easier. Okay, so now the only problem is we have h squared over a squared. I have to square root everything. So that gets me, well, what's the square root of 1? 1. And we have the square root of 6. And it's in the form that they tell us it's going to be in. A whole number divided by an irrational number. So what's m equal to? M is equal to 1. N is equal to 6. 1 plus 6 is 7. So the answer to this problem is, in fact, 7.
Oh my gosh, I was gonna guess that. That's the second guess now.
So fast.
Yeah. Well, so my guess is that this relationship between the area of an equilateral triangle and the hexagon, that's always going to be true. So I'm willing to bet they already knew up front that the side lengths would have a ratio of 1 over square root of 6. That is my guess.
Oh, so then they said 1 over square root of 6 and then 1 plus 6 is 7.
Right.
In like 10 seconds.
Right. So that's my guess. Yes. What's up?
Can you say again the last part starting at the square root of 1 6 equals the square root of h squared over a squared?
Okay, so I took the square root of h squared over a squared.
Yeah.
The square root of h squared is h.
H.
Square root of a squared is a. So that gets me my h over a, which is the ratio it asks for.
And then 1 over the square root of 6 equals h over a because what the square root of 1.
Right. And so they ask us, what is this numerator and what is the number inside the square root, and just add those together.
Oh my gosh.
So it's totally doable. It's just a fair amount of sort of abstract work. But remember when we were working on the proof where we had no numbers? I mean, that's the same basic principle that we were asked to do here. So it's definitely a thing. All right, so let's do this one. This one's pretty quick and easy.
What's that one?
So for positive integers a and b, if a times b is 6 times 8 times 14, what is the minimum sum of a plus b? Well, okay, so the first thing that we're going to do is going to multiply it all together, and we get 672. And so we know that we want the two numbers that are closest, the two factors that are closest to each other. So we're just going to take the square root of this, and we get something that's really close to 26.
Yeah, that's what I did.
So So we know that we need factors that are close to 26. And I can't help but notice that I'm looking at these numbers here, and I know that 24 is going to be a factor of 672, because I can break 6 down into 2 times 3. I can break 8 down into 2 times 2 times 2, and all of a sudden I have my 24, right? And plus I can get another 2 from 2 times 14. So I know 24 goes into this, so I divide this by 24.
28.
24 plus 28 is
52.
52.
Sorry.
I did it. I just kind of